Actually, weirdly, I hadn't put that together. You got space, Antarctic, you got Africa.
You know, you look at these projects and you might think like, what is holding all these projects together? And I think for me, it's the extreme environment.
What's up, guys, and welcome back to another ArchiTech tour. We're here in the middle of Shoreditch to tour around Hassell with Xavier De Kestelier. So Xavier is the head of design and also innovation. He's got a very unique mix of a team where he's kind of design and technology built into what I'd almost describe as a super team. Xavier himself is a pioneer of the computation era. He is one of the directors of Smartgeometry, a major conference that kind of pioneered this in the early to mid 2000s. And he's also really well known for his work with space architecture, which is of course one of our favorite topics here at ATN. So we're going to be touring the office with him. He's going to show us around the office and also talk through some of these incredible lighthouse projects that they do. And then we'll sit down and talk about everything from 3D printing, space architecture to computational design. So I'm personally really excited for this one. So let's go in and take a look. All right, guys, we're here with Xavier. Thank you so much for having us. So you're head of design and head of innovation here at Hassell. Maybe talk us through how many people you have in the office, how many offices you have, because you guys are like a bit of a global firm as well. Give us an overview of Hassell.
Yeah, absolutely. Well, thank you so much for coming over to our studio here in London. This is one of our 8 studios. So we have about 8 offices worldwide. Of course, in Australia, where the company originally was founded a long, long time ago, in 1938.
Wow.
So we've been around for a while. We have offices in Melbourne, Sydney, Brisbane, Perth. We also have offices, quite a few offices in Asia. We have an office in Shanghai, Hong Kong, Singapore, and then we have this office here in London. And here we are about 40 people now. And we serve the UK, of course, Europe, Middle East, and Africa from this studio.
That's quite, so you're quite spread out. And here you've got around 40 people. Is that, what kind of teams? Is it like specialist teams, or do you have designers? Or
Well, we have globally 3 disciplines. We have architecture, interior design, and landscape architecture. And depending on which studio you are, you get certain of these disciplines are a bit bigger or smaller. Right. For example, in London, we have architecture and interior design. But then, for example, our Shanghai studio is really famous for their landscape architecture. So it depends a bit in which studio you are, which one has a bit more of a importance. And then besides these disciplines, we have also many different sectors. And also depending on which studio you are, you get certain sectors that are a bit more important than other sectors. Like for example, in our UK office, in architecture, we do a lot of education projects in the UK. So you'll see quite a few of those projects in the studio.
I'm super excited. I see a lot of space stuff, 3D printed parts. I'm excited. Let's jump into some of the projects.
Yeah, that's good. So in the London studio as well, we have 2 specialist teams. We have one which is the competition team. So we have a competition team that does all competitions besides the ones in Australia. We have a dedicated competition team here in London. And we have also my own team, which is the design innovation team. So we have a few specialist teams that are based in London, but they work globally, really.
We'll definitely get into the innovation team as well.
Let's do that.
Super excited. Maybe talk to us about this space. I guess this is your canteen area.
Oh, so here in our central hub of the studio, so this is where everybody kind of hangs out over lunch, where we have sometimes meetings as well. But it's kind of the central part of the studio. And I have a couple of meeting rooms here as well, and then the main studio is just through that space over there. But maybe I'll show you around a little bit what we have here.
Of course.
So we've set up a few things here too. We have lots of models, of course, lots of kind of, like any architecture firm, lots of models in different types of working. I think anything from, laser cutting, 3D printing, foam models,
You got it all. You've got a good level of models and stuff, I have to say.
Well, yeah, you have to, right? And also kind of, trying to use the right tool for the right model. This part is, for example, 3D printed, while you, of course, laser cut the facade out. and just do the right tool for the right task. I think is
liking
always
this.
important.
It looks very parametric.
Yes, that is for the Brighton Business School. This is a ceramic facade that we did. A larger 3D print of that.
That's very cool.
Kind of see the details of that. That's a project that has now been finished and has been in use for the last 2 years now, really.
Yeah, in Brighton, right?
Yes, correct.
Yeah.
Brighton Business School. We've done quite a few projects for Brighton University. The business school, but also an engineering school, a bridge, and some student housing. But everything from models to kind of mock-ups as well. So what you see here is a project that I'm personally very proud of. It's a project I've been running and is the Bidi Performing Arts Center.
Yeah.
And the project is in a very particular place. This is Bidi, and this is the world's second largest refugee settlement.
Wow.
So this is about 50 miles from the border with South Sudan, northern Uganda. So the north of here is South Sudan. Many refugees coming there. About 270,000 people live there.
Wow.
And of course the UN is very active there for food, for health and so forth. But we had a client there that wanted to do something different and was actually looking at culture and art. And they did a research in the refugee settlement and they figured out that people want to have a place to express themselves, right? And music and dance is really important there. So our client got in touch with a local organization called Sina Locata, and they were founded by refugees. And they're a social enterprise, and what they do is they teach dance, music, and computer skills to the local community as a way to get themselves out of the refugee settlement, to find their own jobs, to find their own, to get their own enterprises going, to find a way out of the settlements.
That's very interesting.
So this project is now. It's been active and operational for more than a year now, year and a half now, and it's been hugely successful.
And talk to us through some of the features. I mean, here you actually made or came up with a system for making the bricks with this crazy machine, right?
Not just models here, mock-ups we have as well. These are not bricks from Uganda. I made these with British clay, really, but it's a nice little mock-up, right?
Yeah.
So what you have to imagine is that it's a very complex space to work because it's really, really remote.
Yeah.
That's the first thing. So you want to use local materials as much as you can.
Yeah.
The second thing is that we were looking at using fired bricks for the building. The problem is with fired bricks is that you need to have wood because they would use wooden ovens to fire the bricks. The problem is 270,000 people living there and there's lots of deforestation happening. So we did not want to add to that. So for that reason we decided to do these compressed earth bricks.
Wow.
Right? Okay. So these bricks are local earth, local soil, mixed with a little bit of cement and a little bit of lime, and they get pressed in this machine here, which is quite a complex-looking machine. But really, what it is you kind of put the earth in here, and close it, and then this thing comes over. I'm not going to do it now, and you compress the earth. 50,000 of these bricks were made. And this was all done with the help of the refugees themselves. So it was a way to also get employment going in the refugee settlement.
That's really cool.
So,
and I guess, I mean, was there sort of like, I'm sort of seeing like a brick pattern going on. There's almost like a parametric pattern. The kind of idea of going from that computation, scripting, all the way down to literally making the bricks is really...
It's probably one of our most computationally heavy projects that we've done.
Really?
And it's for an interesting reason, because we did this project pro bono. So I wanted to make sure that we could do the project, so I had to do it with as few people as possible. So we ended up doing this project, myself really, and one or two other people, and who were very good computational designers, but also really great architects, right?
Yeah, yeah.
And we did that. So this whole model here, which you can have a look at, we have a little axle. Architects love axes, right? Including myself. So the whole model was done parametrically. Yeah. The roof as well, quite a complex geometry, of course, that you see, but rationalized in such a way that every single part of the roof is made out of just very standard material. Yeah. It's straight tubes. It are flat panels, although complex geometrically, it was in the end very easy to install on site.
Yeah, you got corrugated steel roof, pipes, bricks. It's all like fairly straightforward.
It's all very straightforward, but you see these kind of rather complex.
But then you got really
internal
cool
structures. But these are just simple hyperboloids. Sorry, and they look curved geometries. But in fact, they're super simple, made out of straight pieces of steel. The other interesting thing is, you might think, why do you have such a complex geometrical elliptical shape, right? I'm not sure if you remember from your maths classes or geometry classes how to set out an ellipse. But an ellipse you can literally set out by having two pins, a piece of wire, and a pencil. You can actually draw it because the two chords, the distance to the point and the chords, that all is always the same distance.
Right.
So they were able to set this project out by just two stakes and a huge kind of wire, and they were able to set it out super simple on site.
Really cool.
Because that was a problem, there was no electricity, there's no water, so we had to build everything first for the contractors to be able to live on site and then to be able to build the building. So a huge complexity when you want to do something like that.
I love everything about this product. Like it's just like got computation. The power of computation means smaller teams. I always talk about like the 10x team. Like if you do have designers that know computation, fabrication, you got to actually work out how to build this thing. And you've got features. And I think you've also, did I see somewhere you're like collecting rainwater as well?
Absolutely, yeah. So the rain, you can see here, rainwater falling in. Yeah. So, because there is no running water, there is no sanitation really, there's no electricity. So we thought, we need to create this big space. We need to cover it anyway for the sun and shading. We might as well collect all the rainwater. So all the rainwater gets collected in this one point, and instead of having just like a downpipe, we could have done on the side of the building. We made it much more. We want to celebrate the fact that we collect all this water. So you can see all the water being collected in this space, and then it gets filtered to these big containers here, these storage containers, and then the community can actually just use that water whenever they need to. So it's actually for the whole community. They can get fresh drinking water whenever needed.
This is a sick project. I love, like, this is design. Like you're actually solving, it's science and design at the same time. That's cool.
That's what we're trying to. Also, the bricks themselves, the brick patterns are quite interesting. I'm not sure if you can see it here. I'm not sure we have the right drawing. We kind of do. So the brick patterns, we wanted to make sure that the acoustics work really well, right? Because we have a music classroom here, we have a recording studio there. So we work with Arab here in London, and we wanted to make sure there's the right absorption and diffusion happens in these spaces. So what you do see, we have the bricks sticking out, you can see they're here, for diffusion patterns. And in other spaces, I don't have it right here, you see the bricks actually absorbing. There's openings in the bricks that absorb the sound as well. They're called like, a little bit there. This is actually for the light. Really, what we wanted to do is do all the acoustics with one brick. Right, that one brick, there's only one standard brick. We had two of these machines, build the same standard brick, and we want to do as much as possible. So you have openings in the bricks, let light in, we have diffusion patterns, we have absorption patterns, so all of that with one single brick. On top of that, we had to make sure that we had a fully worked out model before we went to the local architect. So every single brick was really drawn in the model.
Okay.
So normally you wouldn't do that if you were working with an executive architect, a local architect, you wouldn't actually draw every single brick out yet at that stage, but we had to do that. So again, it was probably one of our biggest BIM projects in a funny way. Like we went actually we delivered every single brick in the BIM model.
Incredible products. Such a good use of like technology, making. It's the perfect ArchiTech product.
This is some of our other work. There's 2 projects. So one is here in the UK, and the other 2 are in Australia. So we do a lot of museums as well and cultural projects. This is the Geelong Arts Centre, which is Geelong is just outside Melbourne, and this is the WA Museum, Western Australian Museum in Perth. So this project here is the First Light Pavilion, and it's near Manchester, and the site is called Jodrell Bank, and where the Lovell telescope is one of the first big telescopes. I think this one really tracked Sputnik back in the days.
Oh wow!
So we designed a pavilion next to it. It's like a visitor's pavilion. Interestingly enough, we decided in the end to have exactly the same size as the telescope, right? Radio telescope.
Okay, yeah.
And inside, don't have an image here. We reused some of the panels that they had on the telescope inside for display panels.
So if you put the dish down, that's
but then we reused some of the panels inside as well for the display. So that was finished. Oh gosh, a few years ago now. I think 3 or 4 years ago.
That's a super fun idea.
Yeah. So this is kind of related to space, but as you know, we do have quite a few space projects as well. This is the kind of
you are the space. You're sort of the spaceman of architecture, I feel.
So maybe look at some other space projects in here.
Just a quick moment from me to let you know that we're putting on our very first conference called the ATN Summit next year on March 18th and 19th, which will be hosted in Protein Studios in London. It's a 2-day event of talks around architecture and technology where we gather some of the best minds in the industry to share their innovative ideas and stories around architecture. In the build up to the summit, we're going to be putting on lots of workshops where you can learn from some of the world's most innovative architects and some of the most cutting edge tools out there right now. Tickets are now for sale and they're going quickly, so make sure to grab your spot via the link below, and I look forward to seeing you there.
So this is one of our projects we have done for the European Space Agency.
Yeah.
And what was interesting about this project was that we've done space projects before. We've done a project for NASA on Mars, and we've done some other initial projects. And each time we looked at a project for maybe 6 to 8 astronauts.
Okay.
This one is different. This project is really a master plan for space community. This was working with the European Space Agency, looking what it would look like if we have up to 150 astronauts living together. How would you do that, right? And this is actually part of that master plan. You see the bigger slice of the master plan here. And maybe I'll go through some of the ideas behind it here. First of all, you might see these big sails, right? Vertical sails. Well, these are photovoltaics. And you might wonder, why are they just vertical? We don't normally have photovoltaics vertical. Well, there's a good reason for that, and it is because this is a model of the moon. And our site, we did have a site for this project. The site is on the South Pole.
Okay. Yeah.
On the South Pole, on a crater, on the edge of a crater. It's called the Shackleton crater. So, why you want to be there?
Yeah,
for 2
that's
reasons.
my next question.
Right? First of all, the moon has, you've heard of the dark side of the moon?
Yeah.
Right? That is because the moon always faces the Earth in one way.
Right.
Right? And goes around us in this way.
Yeah.
Right? Which means one side actually is dark and the other side has light on. Yeah. Now, if you're on the equator on the moon, a moon day would last 28 Earth days. It would mean is 14 days you'll see the sun, and then 14 days it will be night, which is quite a problem because it gets really, really cold.
Yeah, I was going to.
Right, you don't want to do that. So of course, in the Apollo missions, they landed around the equator quite often, and when it was during those 14 days that it was light.
Okay.
But imagine if you have a base there and it gets really, really dark. So what do? Best way to do is go on the poles, because on the poles, on the edge of a crater, what you would have is you would have the sun on the horizon, and it would go around you over 360 degrees over 28 days.
Yeah.
Which means we have these sails that would rotate.
I see.
Over 28 days, they would just rotate and track the sun. So that's why you see these kind of big sails on our project. So everything has kind of a reason, right? The other thing you might notice is that we, maybe I'll open the model.
Yeah.
It might be a bit easier to see. Let me just take this off, right?
That's very cool.
And so let's start with the first thing is where are our astronauts going to be living? Well, they're going to be living in these pods, in these kind of pill-shaped pods.
Yeah.
Now we previously saw our NASA project where you have these round spaces. Now this kind of inflatable round space are kind of difficult to plan out. Right. So we decided for this project to do inflatables that are more of a pill shape, which means the central part is much easier to space plan. And you have very straightforward,
more
regular spaces that you can plan out, right? Much more easier to plan. Of course, you can't just go from one building to another building on the moon. It has to be all connected, right? But imagine you have many of these spaces, right? So if I live in one part of the base and I want to go to another space, I need to go through all the other spaces, which is a bit weird. Think about it, that you live in a city or in a community. If I want to go from one place to another place, I need to walk through all the other spaces. It's like going from this building to the building on the end of the road and having to walk through every other building.
Yeah.
You don't have a street. You can't go outside. So we came up with this idea of, we did want to create streets, and that's these things, right?
Yeah, it's like human hamster.
Yes. So we're able to just walk from one end of the base to the other one without having to walk through all the other spaces.
Right, I see.
Right?
Wow, super cool.
But on top of that, you also want to get out. So we have another layer, which is this layer here, where you're able to kind of get out with a rover or with a suit port, which are those. So you can get out as an EVA, extravehicular activity. They love acronyms in space. Everything is an acronym. So it's kind of a system on 3 levels. Yeah.
So the philosophy would be these pods would be brought with us and then inflated, so they're bigger?
Exactly, yeah. So we always think of these as inflatables. They probably unfold and inflate. Yeah. So we've looked at a few systems that we could do by doing that. And they would inflate underneath these structures, these shell structures, right? The reason why we have these, very similar to our Mars project, is to protect our astronauts from radiation.
Right.
Earth is fantastic because we have an atmosphere and we have electromagnetic fields. So that really protects ourselves from radiation, solar radiation and galactic radiation. On Mars and the Moon, we don't have that, so we need to protect ourselves.
Yeah.
The best thing to protect yourself is having mass around you. Best place, a cave.
Yeah.
Right? It would be fantastic to protect ourselves. No, we don't have that, caves, or we're not quite sure where they are. Mm-hmm. So the idea is to create our own caves.
Right.
And I've previously shown our Mars project where we 3D printed layer by layer. Here we want to do something different.
Yeah.
Right? So, because we think 3D printing, and I've done a lot of 3D printing, is quite tricky. So we're doing something slightly different, and we're going to work with these hexapods. Right? So this is a hexapod. You might have seen these before in coastal areas.
Yeah.
They help against erosion.
It's heavy.
It's pretty heavy, but hey, you're going to work on the Moon, so it's six times less heavy. 1/6 of the weight, right?
Nice.
And we're going to use that to our advantage, right? the reduction in weight. The way we're going to do that is we want to create these shell structures again for astronauts to live under, to be protected. And the best way we think to do this is not by having really heavily engineered construction blocks and that have small tolerances. No, we're going to work with elements that we can just literally start throwing on top of each other.
Wow.
And constructing something like this. Now,
that's incredible.
How'd you do that? Well, we start off with a big inflatable, like a rough inflatable, like a big
mold.
Mold, really. So it's a big inflatable. As you can see, we're going to throw these little hexapods on top of it, right?
So cool.
One by one. And once that is done, we take this inflatable out, and then we have this freestanding structure, as we do over there. This is the 1 to 10 model. And then afterwards, we bring in the smaller pods and inflate those. So those things will be then inflated underneath these kind of structures.
Super cool.
Yeah.
It's my new catchphrase for the tours, but that's got to be one of the...
So so it's slightly different to all of our space projects. We kind of each time learn from it, and the next one we kind of improve it and kind of find hopefully a better solution each time.
This model here is not, it's not glued or anything, right? Or is it? Is that a trick question?
Okay, this is the trick question. This model, so we've done different ones. So we have done models, and I'll show a video of that later, where we created an inflatable, had all these kind of loose elements stacked and then deflated, and it worked.
Okay.
This one was for a model that was exhibited at the RA last year. So because it was exhibited and being moved around a bit, so we did actually have the 3D printer slightly overlapping.
I see.
You know,
oh, you caught me because it.
I could have fooled you.
Oh,
there's a few loose ones on top, so I'm not
gonna
gonna lie, because it had to be exhibited. We had to make sure it was stable to be moved around a lot.
It's super cool anyway.
You know, and this is about a 1:2 scale. So the real ones will be double the size. We do like to go into quite a bit of detail. Sometimes with our projects, right? And if we're going to have 150 people living there together, what is the one thing they're going to have? A bar, right? So this is a lunar bar, and you might see we like to put like details in our renders that give you a little clue of what is going on. You might notice these chairs. Well, 3D printed chairs, similar to our Mars project. But then also, bit of upcycling going on. This is, you probably wouldn't be able to do it, but this is literally the seat of the Apollo rover, right?
Oh, right.
Maybe using some old rocket parts to make a little table.
Yeah.
And the bar, well, we're not going to bring glass with us, bottles of alcohol or drinks to the moon, right? That would be way too heavy. Every kilogram is going to cost so much to bring to the moon. So we decided to have the bar made out of these bags.
That's really cool.
So all these little details that we like to put in that really starts to make you think what it might look like to live on the moon, right?
And you also did you guys look into the suits as well? Is that something they kind of give you guys?
No, we did look into suits as well. One of the interesting thing is that we are working with these, what we call suit ports. So normally you have a suit, you go out on the moon's surface, you get really dirty, all the particles are really abrasive. And then you need to go into an airlock, then you take the suit off, get something else on, blah, blah, blah. It's quite complicated. Yeah. But it was actually an architect who invented this idea, which is a suit port. Imagine if the suit itself is your airlock. So, and you have it on our model here as well. The astronaut would come to the airlock wearing the suit, hooks himself into an airlock. So actually this is the port to get into the suit. Yeah. And then once it's open, he crawls out of the suit, closes it again, and he's in an internal space, and the suit is still outside. Yeah. So you don't bring in any of the dust.
Wow, right.
So there's the kind of idea of a suit port. And of course, we implemented that in our design as well.
So essentially the door is on your back.
The door is on your back, so you're always bringing the door with you.
Yeah, that's really cool. Like it's such a cool concept, the nest. I think the bar would probably be one of the most important spaces when you're out there.
Too. Well,
you need a drink after it.
It's the thing we've when we do these projects. Of course, you kind of work with engineers and very kind of space-related people. But one of the things we love to do is work with people who have lived in a similar environment. And the most really analog environment you can have is bases on Antarctica. So we've spoken to a lot of people that used to live in Antarctica for up to 8 months, 8 to 10 months, and do the winterization there. So they were there in winter. It's an extremely harsh environment. You can't be evacuated. It's much easier to get evacuated from the International Space Station than it is from a base on the South Pole.
Wow.
Right? Or on Antarctica in the winter.
Yeah.
There's no way out.
Wow.
So super harsh environments. And we learned a lot about speaking to these people and how they socialize and what kind of spaces they need to survive.
So you could say the pub is one of the most important spaces. And since we're in London, this is essentially a space pub.
It is a space pub. Yes, of course. It is really important how people socialize and be able to have recreation in space. So this is a collaboration we did with European Space Agency and EPIC and another company called Buendea. So Buendea is working with us using some of our assets into VR environments where astronauts are actually going to test out tasks. So we worked out with Buendea. This is of course not for astronauts. This is for anybody to play. And you need to go and find helium-3 and water. And the goal of the game is really to build your own base, literally the same base as we designed for the European Space Agency. So it's a Fortnite level. You can't shoot people there. Right? It's an educational game. It takes about half an hour to complete. Although I've never completed it myself, but my son told he can complete it in about half an hour.
There you go.
And you can go, and you can't go inside yet. We didn't build it all up completely, but you can go and find helium-3 water, and if you have enough of that, then you can add more modules and you add more of the protection shield as well. Cool. And it gives you, some information on how it would be to live on the moon. So a completely different way. Again, to show a project, right? So once you've built it all in 3D, you can then just kind of think of different ways of using it, from an AI movie that I showed all the way to a game. And it's probably the most engaging way for people to, see our project.
It's cool. I've zoned out now. I'm playing the game.
No more questions from Ollie.
I can see I've set off these little robots are going to get some
they're going to get some regolith, I think.
I'm collecting these little, things. You can tell I'm also terrible at Fortnite. I don't know how to play, but it's so cool, man. I'm also like a big fan of video games and how you can integrate it into architecture. So this is another epic example. Literally, because you made it.
It is.
It's based in Unreal.
This is a collaboration that we're doing. This is based on our project for the European Space Agency again. When we did our Mars project, we did a very technical and I would say kind of descriptive video of the project. And it was actually one of the requirements of the competition was a 5-minute video explaining the project. So we did this great video with the guys from Lightfield, and that was all done with gaming engines as well in about 3 weeks' time. It was an incredible job. But for the European Space Agency project, we wanted to push it a little bit further. And we wanted to explain the project not from a kind of a standard technical, architectural driven video, which I think architects are quite bad at making videos, I always think, right? We wanted something different, so we thought, well, why don't we make a little short film? So this film is about 7 minutes long, and we started off like a proper short film. We had a storyboard, we had a script written, we had quite a professional crew. We even started to look at actors. And then we figured out it was all going to cost way too much. So ran out of money. Yeah,
they're quite expensive films.
They are quite expensive, right? We were going to use virtual screens as well. We're planning to do that. And I was like, well, but I didn't give up. I thought, no, what we're going to do, I'm going to wait until AI is advanced enough to help us to make this.
Yeah.
Right. We waited about a year and a half now. And about 2 months ago, I thought with VO3 coming out, runway and all that, we were like, this might be something.
The time is right.
The time is right to try it out. So we worked together with a bunch of students from Central St. Martin's. They were here for quite a few weeks in our studio. So we did a collaboration with them while we looked at the storyboard, which were just beautifully hand-drawn sketches, and used those to set out all the scenes, make images of the scenes, and then made in a lot of them Midjourney or Stable Diffusion or different tools really, a lot of photoshopping as well, AI tools in Photoshop, and then using those images to then create little short bits of video. Wow. Again, using Midjourney, Runway, and the VO3 as well. So we're now in the stage that we're going to edit it all together. Exciting to see.
I'll be very excited to see.
So we have the trailer ready. One of the things that we were quite interested in and that we did in the beginning of this project with the students was thinking about the style, because you could very quickly go for the realistic AI style, right? Hyper realistic AI style. We didn't want to do that because I think it would age way too quickly, and people would say like, "Oh, that looks like 2025, late 2025,
Midjourney 7
Midjourney, whatever." So we ended up on this more graphical style that I think is a little bit more timeless. It reminds me of the kind of like animes I watched in the late 80s and early 90s. So we chose a style that is maybe a little bit more, timeless.
Wow, I'd be really love to see that. And it looks like it's based on the project, right? That you just.
It's
explained.
100% based on the project. It's just a little love story happening on our base, right? So instead of just showing the project and explaining how it all works, we just have a story that evolves and happens to be in our project.
I really like that. That's very cool.
So people ask us, why do we have these laptops in these cages, in these hamster cages, right? Well, it's just an interesting way for us to work because everybody has their high-end laptop, and when they come into the studio, take their laptop, sit down, and have two big screens that they can work with. When they go home in the evening, they can put them in here, hook them in, and then at home, if you want to do some work on the weekend or something like that, you just go from your laptop at home or from your iPad and your Citrix into those.
Wow.
So
you can just remote in from your tablet or whatever.
Absolutely. And it of course saves space that your laptop is not sitting on your desk at the same time. And for cooling, we just have them as cages. It works really well for some reason.
Really nice system, because people would always complain like, I'll go lug my laptop home because they're usually bigger and
they're really heavy machines. They're, oh my god, and the power block is huge for these laptops. So we thought this might be.
We've never seen that before. I think it's an innovative solution.
Yeah, it's kind of simple. I quite like simple things. So this is our main studio space where most people work. We have about 40 people here on any given day. Just some models in the middle here, some mock-ups. Everybody can sit anywhere they want. So they take their laptop and sit wherever they need to, and sit with colleagues or form a group for a certain day or something like that. So it's actually quite a flexible space.
Very,
lots of light.
Yeah, I was going to say it's a very London Shoreditch warehouse. We're still in Shoreditch, right?
Yes, we are. Yeah. We are.
Yeah.
So this is quite a simple space, but I really like it.
Yeah, it's very clean. And we have another space project. So
this was actually our first space. This all started with this, really.
This was your first one.
So this is our project we did for NASA, a competition that happened quite a few years ago now. There was a competition to design a 3D printed Mars base. It's again this idea of that we need to protect our astronauts from radiation, right? Lots of radiation happening on Mars, from the sun, from the galaxy. So you see this big shell structure here, right? Just half of it, and that is literally a cave that our astronauts can live in and underneath it. And underneath those, you have these kind of pods that are inflatable pods. You can see them slightly there. I've taken the top off. It's a radial organization, right? Very modular. And the idea is that these are kind of racks. So the things you see there, these are lab racks that are able to move. So you're able to kind of open them up, do an experiment, and then close them up again. A bit like what you have in archives of libraries.
Right, okay.
Right, that kind of the movable racks that you have.
Yeah.
And we implement it for everything. So we have it for the greenhouse, we have it for the living space, we have it for the workshop as well. So all of these spaces are based on the same modular system. Because it's kind of a critique on the current International Space Station. If you look at the International Space Station, what do you have? You have all these tubes, right? These kind of cans, which you can fit in a fuselage of a rocket, or back in the days in the space shuttle, in the cargo bay of the space shuttle. So they're just big round elements. They are all connected to each other. And what you get in the end is just lots of corridors. So space efficiency of the International Space Station is really, really bad.
There's a lot of...
So this is actually critique on the current idea of space stations.
That's very interesting. I also remember seeing the video of these little, what look like these little square things are kind of little robots, right? That print.
So the whole shell structure is 3D printed. And I can actually show it over there. Actually, we have it maybe on the video here as well. So what you can see here is this is our 3D printing system. So if you're going to 3D print something big, you're not going to bring a massive, massive printer to Mars, right? You want to come to something that is light and adaptable. Here we have these, this system. It's almost kind of a Lego system of 3D printers. You have different parts. These are the scout rovers that look for the right regolith. These are the diggers. They go and dig the regolith. This is actually based on an existing NASA design. And then we have the printers themselves that print the regoliths. We have a little video of that one here as well, which I can, which you'll see.
That's very cool.
Then again here, these are a bit more in detail. These 6 pods where we have the living area, the, what else do we have here? The bedrooms, the lab, the greenhouse, the medical bay, and the workshop as well.
Very cool. What's your take now? Because I think with, like, you now see robotics and stuff like that. I know the philosophy with building on the moon or Mars was you just send a bunch of robots and stuff and it builds a house for you, and then you rock up and you just, the keys are there. Versus they also have, like, okay, you bring some pods with you and you live in the pods, and then you and the robots build together. What is actually more realistic? Like, where do you see it going?
It will all happen in different phases. The first buildings will literally be the modules that you land in.
Just like
that will be
bring with
the first. That's the first category of things. The second thing will be that you take those and probably inflate them or add stuff to it. And the third category will be that you then actually start building extra. So they will be all in stages, right? This is a bit more. This is already quite advanced. This is actually the third stage, that you go and start building with materials from Mars, so in situ resource utilization, ISRU, they called it. They love an acronym. They
do actually have the word, I remember from the IAC course, there are like Cat 1, Cat 2, Cat 3 or something for the...
that's Cat 3. There's different categories of types of buildings. But we, of course, we love to build these things as well. So we were very lucky that once we finished that project, there was an exhibition happening at the Design Museum in London, and they invited us to go and build one of these pods. So we went and created one of these inflatables. It's an interesting inflatable as well, because we wanted this to be a space that any visitor to the museum could walk in and out. So we couldn't have a normal inflatable where we normally need an airlock, right? On Earth, you would normally have, if you're big inflatable buildings, you have an airlock, right? We couldn't have that. So we decided to build it a bit like a kite surfing kite, right? So you have all these ribs, right? And in these ribs, you have inflatables, right? So it's like a big kite surfing kite at the end of the day.
Yeah, because it's not airlocked, you need that kind of like inflatable structure.
Yes,
If it is, it's more of a
It would just
bubble.
be yeah, you would
Yeah.
have a bubble.
Yeah.
We wanted to have a full experience, so what we did, we worked on this idea that when you looked out, you had this huge digital screen. That was all built again in Unreal, so people could sit there, watch, look outside. This is without the bubble there, but you see the screen better, and you can see other astronauts walking out. You can see the day was changing as well. So it was really a real immersive experience to being in that space. And then, we also looked at the furniture. So one of our ideas was to use 3D printing as a way to create the furniture, because you're going to have lots of waste, right? You're going to have plastics from food packaging or from experiments.
Yeah.
So what are you going to do with that plastic waste? Well, maybe recycle it into 3D printing. So all the furniture on our base, we wouldn't bring this furniture, you would actually go and 3D print it locally.
Yeah.
So, and of course for that we worked together with a company called Nagami to do all the furniture in the exhibition as well.
Yeah, very cool. They did some really cool stuff, particularly around furniture, right?
Yeah, absolutely. So we've done another project with them, a much larger pavilion that we're doing at the moment. That's still in the making.
We'll check that out. It's so cool. So this was your first space project, then the one you...
Well, it was my second one. I did when I was at Foster's at a couple, and this was my first at Hassell, really. And what's important is that we looked also at not just the architecture, there's the architecture, but the mission architecture as well. Looking at how many modules that we needed, how many launches that we needed, how many times we have to send stuff to Mars, a big timeline here, and to kind of work it all out. And for that we worked with system engineering students from Ghent University. So it's not just us coming up with it, we actually worked with experts on this.
That's what I like when you do these space projects, you often work, like we did one at Big with NASA, and you actually present to scientists. They're just not going to buy any bullshit.
Absolutely, and I think the way we run these projects as well, we very much run them like a design project with all the astronauts and the scientists and all that. So what we do in the middle, that we've done it a couple of times now, we organize a design crit. So we organize a micro symposium, invite lots of specialists. We have the room full of our drawings and design, and then everybody gets a red pen and a post-it and can start drawing and saying what they think is wrong. And the conversations are amazing.
The ultimate crit.
Oh, yes. And also the great thing is the scientists don't agree always, and the engineers. So we have some really heated conversations happening as well. And it's interesting because they're not always used to reviewing each other's work like that. They're more used to doing a peer review through maybe a science paper, right? So this whole loose way of looking at a design in a design crit is something that they're not used to.
It's a bit like online beef, and then you put everyone in the room.
Absolutely, So but
so
it's
a
super
crit
helpful.
by literally rocket scientists.
Yes, absolutely. So this is maybe an interesting project here. I just hung it up here. This is literally a next generation lower Earth orbit station. International Space Station. It's getting old. It's older than 20 years now. And it needs a
Bit of a makeover.
Needs a bit of a makeover.
Renovation.
It probably needs a new generation station. NASA has been funding 4 different companies now, and we've been working with one of them, and that is called Orbital Reef. Orbital Reef. So this is next generation lower Earth orbit space station. It's a collaboration between 2 companies. It's Blue Origin, Jeff Bezos' space company, and Sierra Space. Sierra Space delivers this module, and that's the one that you see right here, right? And we've worked with them to show you that it is real. This is one of the test modules that they are building, right? Again, an inflatable.
Yeah, I was going to say, what? Wow.
It's an inflatable. And we've been looking at that to how can we, fit this out in a little bit of a nicer way than the current International Space Station, right? So you can kind of see some of the drawings. And for every project, I have to do this kind of AXA line drawing.
Love a good AXA.
We have this big space, which has, because you're in space, what way is up and down?
I guess you can just float around.
Yeah, but from a psychological perspective, NASA really wants to have a direction in a space. So it's really important to always have the same up, down, left, right. So what is a wall, what is a ceiling, what is a floor? Still very important. But it doesn't matter always which way up or down. So what we did with this kind of awkward inflatable space is that we said, okay, well that way is up for this floor, and for that floor that way is up. So we just mirror.
So you're saying you got the same reference of the roof.
So the space is always, and of course it's better to have a space where the ceiling curves over you than the floor curves away.
Yeah.
Right. So and then the life support systems kind of sit in the middle of that.
Wow.
The other thing was this space here, this volume. This is a hard shell volume. It's not inflatable. This one was quite awkward because the diameter was quite small, and so instead of organizing it in this direction, we decided to organize it in that direction, and you get a module that has no floor, really. So it's kind of a vertical space, but you are in space. You don't need a floor, right? So that one is a kind of more of a vertical direction. I think I have a drawing of that here somewhere. Yeah, here we go. That's it. Oops. So here you have the kind of vertical volume, and that would be like a control and lab space.
Wow.
And of course, a big view out.
Big, nice
You always
window.
need that.
Yeah, these space products, you just rethink everything. Gravity doesn't even exist in some ways.
Well, you have to.
It gives you really tricky.
Because it's in lower Earth orbit. So, but you have lots and lots of constraints, of course. Right. You have limited space, but it's just an interesting way of kind of going back to first principles as well and kind of thinking around that. And that's what I love. You have to think again. What spaces mean, how they're going to be used from first principles.
Very cool.
What else do we have? Another collaboration here that we've done with the AA and the MTech unit. This is kind of interesting because the students there normally make pavilions, so they've done a lot of wood construction pavilions with timber. And they like to use digital fabrication. They love to use their robots and all the milling machines.
Love a good robot.
Yeah. But we said, well, instead of using this nice, new, perfect plywood, why don't you go out and get the cheapest wood that you can find and the cheapest recycled wood you can find? And that was this wood, which is just pallet wood, right?
Right.
The cheapest thing you can get, right? And they created these curved elements, right? And it was quite tricky because, of course, these pieces of wood aren't the perfect size, aren't perfectly, they might have nails in or something like that. And they were able to kind of, do little cuts in them. They made their own little steam boxes and able to create these curved elements. And, after they had it on the at the Bedford Square for a few weeks, they were going to recycle it, and we said, well, maybe just come bring part of it here in our studio so we can actually talk about it.
Okay, so they're made from pallets, and then did you guys, I assume, script it beforehand? So you molded
it was the students themselves. They were actually kind of doing the scripting. We really gave them the challenge.
Okay.
So there was also the interesting thing was they made an AR model, so they use a HoloLens as well to kind of on-site being able to kind of assemble it.
I see.
So.
That's really nice. You can take that to, I feel like this could be a cool Burning Man structure or something like that.
Yes, that's true.
But that's great. It's really cool, like low cost, but again, high tech.
Yeah.
Use of computation and augmented reality.
Absolutely.
Pretty cool.
Now you might have seen these 3D printed chairs we had in our Mars project. And this is then kind of the next step of that, right? So, this has a bit of a history behind it. We did the Mars project. We were able to kind of create these large pieces of furniture. But we started to think, well, if we can do these large pieces, we can probably maybe do parts of architecture, parts of buildings. Well, why can we do it bigger, right? And at that point, we had an opportunity. We were invited by the Norman Foster Foundation to run one of their robotic workshops. So we used that as an opportunity to start thinking with 10 students back then. Could we actually use the advantages of 3D printing and the geometrical advantage that we have to create building blocks, facade elements, start to conceptually think about that, what I could do. But that was just a week workshop, which was fantastic fun. But then we found one of our clients who was interested in it, and we said, okay, let's push it even further. So for that, we've actually now working on a project which is a fully 3D printed pod or meeting space. We can have a look at it over there. Yeah. So this is this 3D printed pavilion, 2 renders of it in 2 very much different locations. This is a glacier somewhere in Europe, and this is a beach in Senegal. It looks like a similar architecture. It is similar, but it has morphed into something else. You can see the two versions here. Yeah. This is the one on the glacier. What you see here, quite small fins on the skin. They kind of stand up. Yeah. What do these fins do? They capture the snow. Right. And the snow itself becomes a thermal insulator.
Like a snow jacket.
Right? For this one, in Senegal, well, these fins are grown much bigger, much thinner, and they kind of overshade each other. So these fins are actually for shading. And this also has cross ventilation in. So it's kind of the same project, but it morphs itself parametrically for different locations.
Yeah, right? That's a really cool way of 3D printing. Like it's, sort of the same form, but then it adapts to the environment.
Fairly similar, but it adapts. And you see here, like, we're about 80% there. We have an internal structure, an external skin, and an internal skin. You can see here, this is being done again at Nagami's facility, where we have big ABB robots with a pallet extruder printing those.
So these are made in modular parts. So you can kind of see they connect together, and then it's assembled and put into place.
We started off, and you can see it here, thinking we can do everything in one go. So we can do like the internal skin, the structure, insulation, and the external skin in one go. But it became way too complex on to kind of how these parts would come together. So then we decided to have an internal structure, right, where you can do all the connectors, and then you have the external skin, which is on top of it, and then an internal skin. Right. So, three different elements that come together.
And you've kind of made one. Where's it going to go?
We had a location that changed again. Yeah. So we're still now working with a client on a location. We're kind of 80% there, so we need to find a location soon for it.
Okay. Stay tuned. It could be.
Stay tuned.
Could be seeing it in your neighborhood.
Indeed.
That's really cool. Yeah. Really cool project.
Cool.
That's great.
For the rest, we have a little model shop here. We don't have huge model shops, but because we are
Ultimaker.
A little Ultimaker, we have 8 studios, so every studio has their own little model shop. So there's not kind of one studio where the models get made. There's not one of our studios is much bigger than the other ones. So this is a smaller studio really from our 8, but everybody has either a laser cutter and an Ultimaker.
Do you guys find, since you're so into the 3D printing side, we see a lot of Ultimakers on tour. We see the Bamboo Labs printer taking over. Or do you have an interest in one, or like anyone's?
Well, I want to test the latter one out, but we have to have these ones now. But
Ultimakers seem to be the ones I see everywhere.
A few years ago, they were quite. They were kind of the ones that everybody was having, so they were quite decent, but always open for new ones as well. We'll see where we go next. As I explained, we have quite a lot of education projects, right? The Brighton project that I mentioned, we did a big master plan for Brighton University, where we had 2 projects that did student housing, which are these, and also the Brighton Business School. This is this kind of, that parametric
that we were talking about.
Yeah. These are all ceramic tiles in different sizes. You can see it here as well. And then 2 more buildings. This is one in Edinburgh, the Usher building, University of Edinburgh. That has just been finished and being used. And we have also a project now in Glasgow, which is finished as well.
Right.
So lots
Really
of
nice
work.
projects. These are student accommodations?
There's student accommodation, yeah.
Looks
I
like
wish I stayed in one of those when I was a student.
I was going to say, looks like premium. Really cool.
So yeah.
And this building was, is that part of the school, or is that
That's
also
the business school.
That's
There's the
actually
business school.
yeah.
There was an engineering school as well, but it's part of a much larger master plan, which you can see here. So that is the master plan. So this is the engineering school, the business school that you just saw, and
Right.
this is one of the student housing. This is the other one. So kind of 2 blocks of student housing, and then a bridge in between as well. So it's kind of full master plan. We started this about 10 years ago. And over the master, so we've been able to kind of build quite a few of the buildings on that master plan.
Yeah, it's a big project.
So this is our second project in Africa. This is in Tanzania, a project called Hope Village. And it's a project that is, so what you see here is the community center. It's actually part of a much larger project. And it's a project where we will have 200 girls being housed who have a history of abuse. And so it's an organization that takes care of them, and they are living independently in different houses together, 20 girls together each time.
Yeah.
And the client wanted to see if we could design a community center for it, like a community hall. They would also be used partly with the local community, local village. Right. So the project had to, the brief for the project to have a large open span space with a kitchen attached to it, and you could do performances in the space, but it could also be church, it could also be for evening meals. Right.
So similar to the other projects. It's
A little bit
community
similar.
Center.
So we did 2 things. This is 2 parts of this building again, is the walls and the roof. Right. For the walls, we collaborated with IAC, Institute for Advanced Architecture in Catalonia, and because they are one of the experts in 3D printing with earth. So it's kind of taking the project that with the Bidi project a little step further, and instead of just doing bricks, we wanted to see, can we actually 3D print with earth?
Wow.
So, and part of the project was actually building a 2-meter wall of this project in situ. So we've done it not in Tanzania yet, but this was done on the site of IAC in Barcelona. You can see here on the rendering, what we kind of learned for what it would look like. You kind of see that represented in these renders.
Was there kind of philosophy for the
Well, to have light, but also to get airflow going through. So we want to get to naturally ventilate the building as much as possible. And then we were thinking, like, how are we going to do a big, large span structure, right? But as few columns as possible. We sent out one of the team, Edouard Cabet, he's one of the directors, I think he's director at IAC, to Tanzania. He said, like, yeah, I want to go. And he went to check out what the local construction technology was. So before we designed this, we actually wanted to understand what local materials, what can you build with. There was a lot of steel, there was some concrete, but from a sustainability perspective, we want to see, can we do wood? We went to the local wood fabricators and found out that all the large sections of timber were actually exported to China, Middle East. So what you have left is smaller sections of timber. And we thought, well, what are we going to do with small sections of timber? And then we came up with this idea here, right? To kind of take small pieces of timber, about 2 meters long, and kind of rig them up with a metal wire and some spacers. And what we could create is literally a tensile structure, a wooden tent structure. So we call it the wooden blanket. So we worked with EOC, Eckersdale Callaghan engineers on this, and you can see that, well, kind of best here in this render. We used, of course, kangaroo and other kind of form finding techniques to find what that ideal geometry would look like.
Wow,
You know?
that's really cool.
So we're still in the funding phase of this, so we need more money. The client needs more money to be able to get this constructed, but hopefully we can get it done really soon. The idea was also with this timber tensile structure that it could be built fairly simple. So you have this kind of central spine, right?
Yeah.
This kind of Y-shaped spine, which is just built in local steel, and then from that you can just rig it up with kind of simple scaffolding. You kind of hoist up one by one these kind of blanket pieces.
Yeah.
Right?
And then a little 3D printer that you move around?
Yes, so based on a WASP printer that EAC is already using. And we were even thinking, could we actually leave, once this building is done, we leave the WASP printer there, kind of educate the local community on how to use this technology and see what they would print with it. You know? Super
cool. Again, really nice mix of computation, design, actually building stuff.
Well, that's what we're trying to do is and this is kind of, I think, a little bit, you know, we are kind of a design technology-ish team. It's a little bit different than the standard design technology team that normally just is at the service of other projects. We also do our own projects. So these are our lighthouse projects. This is kind of 50% of what we do. But we use these as an excellent excuse to start testing out new tech. Because what I don't want to do is just use new tech just for the sake of it, right? Because it looks cool, because it's like flashy or whatever. I really want to use technology on projects myself first sometimes to kind of understand what value does it have, and you know, and so technology has values that you didn't expect. Like for example, on the Bidi project, we used a HoloLens. The best application for a HoloLens was us using the HoloLens on site with Educator, which are the founders of the organization there, looking at what the building would look like on site. So that was a great application for it.
I really like that. It's like using technology in practice first.
Absolutely, and it's not always the flashiest tech that has the most impact. I'm really always really concerned by looking at the right technology, which sometimes can be quite simple, that has the biggest impact.
Thank you guys once again for joining us on the tour. Incredible office tour, but stick around for part 2 where we're actually going to sit down with Xavier and talk through all of the technologies and projects in a bit more detail, so you can follow that up in the next video. As always, if you like this video, give us a like and a subscribe. Just hit that stupid button. The bigger the channel gets, the more places we get into. And also don't forget to go and check out our online courses. That's basically how we fund all this. Otherwise, thank you for tuning in, and we'll see you in the next video.